Is material A stronger than material B? Unlike yield stress of a ductile material, strength of brittle material is unspecific until a particular type of test piece is fractured in a given manner. Materials like ceramics are weak in shearing and tension, but have strong compression with high softening temperature. Ceramics are hard and brittle. One of the parameters to be examined in the ceramic material is its mechanical strength under mechanical properties. But how is one able to determine its mechanical strength? Using the usual tensile testing is not possible in ceramics due to its brittleness characteristics. Ceramics are hard to shape into the proper test structure. To grab the brittle material without breaking is difficult. An alignment of the test samples to avoid bending stresses, which can destroy the sample, are difficult to perform. So, a transverse bending test is used and a modulus of rupture, or MOR, is determined. But what is modulus? Or flexural strength measures the bond strength of the test specimen. For castables, it measures the bonding strength of the cement matrix. In a flexure test, modulus of rupture in bending is the maximum fiber stress at failure. In a torsion test, modulus of rupture in torsion is the maximum shear stress in the extreme fiber of a circular member at failure. For ceramics, modulus of rupture is defined as the point at which cross-section of the material will break. Usually, flexural strength is the amount of force an object can take without breaking or permanent deforming. This really tells you the maximum amount of stress the material can take, and it's quoted as force in newtons or pounds force per unit area in meters squared or squared inches. But how is flexural strength or modulus of rupture determined?
There are two convenient ways to test and measure the modulus of rupture, through a 3-point bending test and 4-point bending test. For a 3-point bending strength test, a continually increasing load is applied in the center of the sample until there is a break or permanent bend in the material. The maximum stress is present only at the center of the beam. A flexural test machine can apply increasing amounts of force and precisely record the amount of force at the point of breaking. For a 3-point test, the flexural strength given the symbol sigma can be calculated using sigma is equal to 3Fh divided by 2b multiplied d squared, where F means the maximum force applied, H is the length of the sample, B is the width, and D is the depth of the sample. So to calculate the flexural strength, multiply the force by the length of the sample and then multiply this by 3. Then multiply the depth of the sample by itself, or just square it. Multiply the result by the width of the sample and then multiply this by 2. Finally, divide the first result by the second. In SI units, lengths, widths, and depths will be measured in meters, while force will be measured in newtons, with the result in pascals or newtons per meter squared. In imperial units, lengths, widths, and depths will be measured in inches, and force will be measured in pounds force, with the result in pounds per square inch. Four-point test flexural strength calculation. The 4-point test uses the same symbols as the 3-point test calculation, but with the assumption that the two loads or forces are applied, so they split the sample into thirds. It looks much simpler. Note that this is exactly the same as the flexural stress formula for 3-point tests, but without the factor of 3/2. So simply multiply the force applied the length, and then divide this by the width of the material multiplied by the depth of it squared. Now, what is the significance of modulus of rupture? First, it aids in the study of materials and their properties. Second, helps in designing structural elements like composite beams, ceramic tiles, and etc. Third, provides parameters for stronger constructional development. Fourth, contributes in judging the quality of structures used for constructions. Fifth, resistance and durability of objects can be predicted. So the question now is, what bending type to use? According to some ceramists, it is said that 3-point test is recommended for homogeneous materials like plastic, while 4-point bending test is more suitable for non-homogeneous materials like composites, which is stiffer and more brittle in order to avoid. If you need to figure out how strong a material is, one way is to test how easy it is to break. The modulus of rupture, also known as the flexural strength or transverse ruptural strength, gives you the maximum load capacity right before a material breaks. For a material like wood, the modulus of rupture has applications in engineering and construction.